Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. With all of the definitions and discussions that we've had about S5, we are now in a position to start getting to do something super cool, something that we haven't actually done in any of the other systems that we've looked at across this entire series of videos. Namely, we are going to prove that S5 is complete. Now, it's been a while since we've talked about soundness and completeness, so let me just briefly remind you what this is. Completeness is a statement about the relationship between a proof system, so something that generates theorems by applying rules to axioms, and a semantics, or in the context of Kripke semantics for modal logic, a class of frames. So I've shown you that all of the axioms for S5 characterize a particular class of frames, namely the ones that have a relationship that is reflexive, symmetric, and transitive. What we want to do with completeness is to show that anything that is valid on the class of reflexive, symmetric, and transitive frames, so it's true at every world, no matter what valuation, what model you take, this is going to be something that we can, in fact, derive in System S5. That's the nature of completeness. What's particularly cool about the procedure that I'm going to give to you is something specific to S5. It's not going to work for weaker systems. Not only am I going to be able to show that every formula that is valid on this particular class of frames is derivable in S5, I'm going to give you a mechanism for how. It is a foolproof mechanism for any formula. What you will do is first you will test, is it valid in the class of frames or not? If not, it's not true in at least one world, on one model, in one frame, we're not interested in it. Or it is valid, in which case it will have some particular format, some particular structure, and we will use that structure to generate a proof of it. So this is super cool. Now, the process is going to involve a whole bunch of definitions and manipulations and take this and do that and change it to this and move it around and do all of these things. So it might be a little bit definition heavy at the beginning, but they're all relatively straightforward definitions. And because they are the sort where they basically tell you, take this formula and manipulate it until you get this other formula, which is semantically equivalent to it, you get to do a lot of fun things. So you can like write down random formulas and test them according to the procedures I'm going to give you and convert them from one format into another and vice versa. And I don't know. This is one of the parts where logic starts getting lots of fun because it's basically little puzzles and games and tasks that you can do. And it's all going to be mechanical. So even if you don't quite understand what's going on at the beginning, you can still do it. And hopefully, if you do it enough, you'll eventually understand it. So this is a bit of an introductory video to what we're going to be doing, which is namely to give an effective completeness proof for System S5. So join me later for the first of the definitions because, woo, we love definitions. Until then, take care.